Welcome to the Planet of Maths channel. In this episode, we will talk about trigonometric functions of acute angles in a right triangle, and this will be the first part, meaning we start from the basics. We have a right triangle, because that's what we'll be talking about in this episode, and we'll be considering what trigonometric functions of acute angles are, that is, angles alpha and beta. In every textbook, you can find the rule explaining what sine is, what cosine is, and so on. I won't talk too much about these formulas here. I'll talk about how they work in practice. What is the sine of angle alpha and the cosine of angle alpha? These two functions, this sine and this cosine, they have one thing in common. The hypotenuse always goes to the denominator at the bottom. If we look at this triangle, the right angle is here, the hypotenuse is here. So for the sine, the denominator gets the letter A, and this same in the denominator of the cosine. This is the common part of sine and cosine, but the difference will be at the top in the numerator. If we take sine, it might be on the basis of such an association. If we want the sine of this angle alpha, the sine shoots like an arrow straight to what is opposite angle alpha. So in this case, it will be the side C. In the numerator of sine of angle alpha, we have the opposite side C. If we want to write down cosine alpha, starting from this alpha angle, here we cut with a scythe like this and don't go stray, but turn towards the adjacent side B. The adjacent side B, which is next to this angle alpha, we place in the numerator of cosine of angle alpha. Here there is B. For the tangent, we need to remember that the hypotenuse does not go to the tangent, so the letter A is out here. It must be letters B and C. And we need to start, like with the sine, if there is C in the sine, it will also be C at the top in the tangent. This letter must match the sine and tangent. So it will be C divided by the adjacent side, that is B. This is how it looks for angle alpha. Now let's look at angle beta. If we want to write the sine and cosine of angle beta from the same triangle, we also put the hypotenuse in the denominator. So here is A, and here is A. The sine of angle beta, this one, from this angle, the sine shoots like an arrow straight to what is opposite to it. So we have the letter B here. This goes to the sine. And the cosine of angle beta, from angle beta going, we cut with a scythe that turns not to the hypotenuse, but the cosine turns towards the adjacent side. In this case, the side C. We have C in the numerator. For tangent beta, without the hypotenuse, starts like sine. So in tangent, we will have B at the top. And in the denominator, we put C. That's roughly how it works. In a specific example with numbers, we have here the legs of 5 and 12 and the hypotenuse of 13. We have to write what will be equal sine alpha, cosine alpha, and tangent alpha. We have alpha here. Beta is not really of interest in this problem. We are mainly looking at alpha. In sine and cosine to the denominator, we put the hypotenuse. The hypotenuse is 13, which is the longest side in the triangle. The hypotenuse goes to the denominators. And the sine of angle alpha, so from this angle we shoot like an arrow straight to what is opposite to this angle. We end up with side of 12. This 12 goes to the numerator. Sine is equal 12 over 13. And the cosine of this angle, we start from angle alpha, and as if we were cutting with a scythe, it bends towards 5. So cosine equals 5 over 13. In tangent, we can't put 13 to the tangent. The hypotenuse is not considered here. At the top to the numerator, we put what we have in sine. In sine, we have 12, which is opposite this angle alpha. Opposite angle alpha, we have 12. In tangent, it goes up. And the denominator is the other leg, which is 5. In the third example, we also write down sine alpha, cosine alpha, and tangent alpha. The angle alpha is here, so we are focusing on this angle. Beta does not concern us. Sine and cosine, as we remember, we put the hypotenuse in the denominator. The hypotenuse is the longest side. That is the square root of 13. This is in the denominator of both sine and cosine. Now the numerators, sine of angle alpha, it shoots like an arrow straight to what is opposite to it. So to the leg of 2. we have 2 at the top. But we can't leave this result as it is because we have a root in the denominator. We need to rationalize it. We multiply the numerator and denominator by the square root that is in the denominator, so times the square root of 13. And up there, nothing special happens, and below, 2 identical square roots give us the number from under the root, which is 13. And here we have sine. Now we still have the cosine of angle alpha. The angle alpha is here, and the cosine is like cutting with a scythe. It comes out of this angle and turns not towards the hypotenuse, but in the other direction. To the leg adjacent to angle alpha, which is to the side 3, 3 goes to the numerator. Once again, we have to rationalize this fraction. So we multiply the top and bottom by the square root of 13, which give us that result. And we still have the tangent of angle alpha. At the start, it shoots like the sine. The tangent goes to the 2. We start tangent in the same way we started with sine. And to the denominator, we put the second leg, which is 3. And that's it. There's nothing more to do here. There are also examples where we only know 2 sides, but need to know all 3 functions. We can start with sine and cosine from their denominators, because we know here the hypotenuse, meaning a side which is opposite to the right angle. 7 goes to the denominators here and here. We could write down one function, but which one? If we were to write everything for angle alpha, if we were shooting like an arrow, we would end up with the side x. We don't know that, so we don't know the sine either. But if we were cutting with a scythe, we would end up here. And this side we already know, so we put 6 to the top of cosine. And that's all we know for now. We don't know the rest yet, since we don't know x. But we can calculate this x because we can use the Pythagorean theorem. First, we take the longest side of the triangle, that is hypotenuse, and that is 7, and square it, equals x squared plus 6 squared. We calculate 7 squared, that is 49. X squared is x squared, and 6 squared is 36. Now we need to subtract 36 from the both sides of this equation so that the number 36 disappears from here. After subtracting, I get 13 from this. That equals x squared. After taking the square root, x is equal to the square root of 13. We already know that x is exactly that much. Now we can complete what sine is. Sine shoots like an arrow, so we end up here. The square root of 13 goes to the numerator, and that's all that needs to be done. There's no irrationality in the denominator. In the numerator, it doesn't bother us. Sine is there, cosine is there. Now the tangent alpha, so tangent is like sine first, meaning the square root of 13 on top. And in the denominator, we put the other leg, which is 6. We have the tangent, so we have the complete set. That's all for this video. Thank you for watching, and invite you to watch the next episodes on the Planet of Maths channel.